Right, so from this point on I'm going to start moving fairly quickly. I was doing some background research for this next tutorial, which is for the PWM side, and one of the things that became very quickly apparent that I'd actually got the system on the wrong pins, and basically what I needed to do was move the top three. The pin 6 was fine, but 12 isn't a PWM. I've read the documentation wrong, so I need to move down to 9, 10 and 11. So I've done that on the hardware, so let's go to the actual screen. So what I need to do now, and this is the nice thing about object oriented programming, I can now go in and they say 9, 10 and 11, and that's the only change I need to make on the software, because every command is automatically altered, and this is where you really do start benefiting from doing object oriented programming, where this would be a nightmare if you do actually use the pin numbers all the way through, because you'd have to either do a replace, and the trouble is that there are a lot of numbers that are 11s, a lot of 10s, a lot of 9s, and so you end up with this horrible situation that you're altering things that you don't want to alter, as opposed to putting the effort into giving it all a name at the beginning. The computer doesn't care. It doesn't care whether you store it in a box. The computer, the chip doesn't care whether you put it in a box or not. It just sees it all as data and processes it. So we go back to that. So now then, so what we've got is 9, 10 and 11 are the new motor pins. What I'm also going to do is add in another integer. I could do it as a byte, but I'm going to do it as an integer of my PWM, and I'm going to say equals, and I'm going to start this at 80, and we could go right up to 255, but let's see what 80 does. So we've got a situation where we've added a new variable. Now then again, because object-oriented programming works on everything as a concept, all I need to do now to go over to pulse width modulation is first of all change the digital to analog, which what I can do then is, having done the first one, I'm having a lot of fun with this mouse. It's not its normal position, to be honest. And then I can go through and say edit, where are we? Replace, find, and then I want to put analog right in there and digital right there. Let's say replace all. So what's happened now, that's gone through, and then all our little procedures alter that to analog right. Now that does also mean that the other side doesn't work, so what I'm going to do is go back and grab my variable, which is my PWM, copy that, then go back down to where it says hi, I'll alter that to what, and again, because it's object orientated, we're now created a situation where lows want to be 0, situation where if we want to change that, we can change it globally very easily. Now I could go do a replace on all these, but let's just be certain that we're getting the right thing for the sake of the 2 minutes it takes to go through this. And last one. in no particular order. It's got the inserts come on, so let's put the bracket back in and the semicolon. And low may have also worked, because low is effectively 0. But we've changed it over properly. It's all. So now our object orientation again comes in, so that all the rest of the program still works. And we've now got this. So we're now right. So we've now got a situation where we've got we've added the PWM variable, and then all the way down here we've altered our analog rights, digital rights to analog rights. So let's now put that onto the robot. And we should notice that the wheels are now going a lot slower, because we're effectively telling it we're running a lot lower voltage. And let's see how much of a bumpy bot that leaves it in the arena. Now what that does show is that one of the problems that we've got is that we need to swap the logics, because it's really now that it's not skid steering and getting away with it and making it look like a much cleverer robot, it's actually just sort of dancing on the spot. So what I'm going to have to do is go over and very simply, again using object-oriented programming, if I go in and say I want to alter, sorry, thought the robot right switch and left switch, then that should do it, because I'm going to have to go and grab the robot. Hopefully I won't drag my tight-clip mic off. Ew. So what that's allowed us to see is that what initially looked like very clever programming was really just a robot skidding around the arena, actually bashing into everything and getting away with it. In reality, what was happening wasn't very clever, and it wasn't actually doing the job. So, as I said, I've gone in and I've now switched over the right and the left command, because it was literally pulling itself back into the same position. And so what I'm going to do now is send that to the robot. And let's see if that makes a little bit more sense, because it probably wasn't obvious, but I was quite aware that really I was getting away with murder, and the robot looked far cleverer than it really was. In reality, it was failing miserably. Right, so we'll go back to the arena as I grab this little guy off his stand. And let's see if that improves the programming any. So what we're starting to see now is, again, how the logics can very easily get stuck in a corner. Now this is what I actually wanted to start looking at, because it's all well and good thinking that you've done sensible programming, but if we actually go back, I mean, that robot, no, it's got out, but that's more by entropy than good management. In reality, you've got a situation there, although we're moving things about, it's doing a lot of bumping into things. And if that was a robot vacuum cleaner, you'd be ringing the manufacturer up and saying this robot isn't very good. So let's now start having a look at what we can do with the programmer to try and stop that getting locked into corners. If I grab the robot again, luckily it's come down this corner, and so we'll stick it back on its stand, I'm pulling it back into the programming now. The advantage to it running a lot slower is that it is allowing us to see where the flaws really are in the software. So what I'm going to do is I'm now going to take the time base up to 500. Because what that should do is mean that when it's doing its reversing, it's just getting twice as much time to get away from the wall. Now if I'd actually put batteries in as a lower voltage, I am going to go back in while it's on my mind and take that time back up to 5 seconds just to stop the robot setting off too quickly. Give me a chance to put it in the arena. There we go. So we're programmed. And it did its 5-second wait, so we'll take it out of the computer. We'll go over to the arena. As I'm going across, I will press the reset. So we've got the 5 seconds before it starts. So we're now starting to get a lot more sensible reactions from the robot. If you notice, we're still getting trapped in corners. And that's down to the way that I've actually done the logic. Now we've got away with it then just by pure entropy, because if you notice, one motor's running faster than the other, which again, who wants a robot that goes around in circles? But we're getting away with some of it purely because of the fact that it's a cheap robot build. It's going to get stuck in a corner again. So I'm not going to do a lot more with this tutorial, but now you can start seeing how we really need to look at logic. So we really need to look at, well, what are we saying and what other sensors might help us make better decisions, because 3 switches don't really give us a lot of options with regard to how we do things. As I'm looking at it, there is one other thing I could do, and I wondered, I did consider just then going in and actually putting in a command where if we get the middle switch, it goes left one time and it goes right the other. But for this tutorial, it's a bit more than I wanted to show, so we'll go back to the robot getting itself lost in the arena. But the nice thing about the object-oriented programming is we've proven how easy it is to take it over to pulse width modulation. But that has also allowed us to see the error in what looked like clever programming. So I'll call that a do for today's tutorial. We've capitalised on the object-oriented programming, but now we now start seriously looking at logics and what we are trying to achieve with these bots.